In this video, I'd like to go over 3 graphs that I find that students often have difficulties with. The first one looks like this. And my first thing I wanted to review here is that the slope of the position graph tells us the velocity. So you can see that the slope here is getting flatter and flatter, and it is a negative slope. All right, so just a quick review. This would be a negative slope. This would be a 0 slope, and this would be, this is a positive slope, 0 slope, and then this would be a negative slope. Okay, so this is right here a negative slope, so we're going to have a negative velocity, and then it's getting close to a flat line, so 0. So this is 0 right here, so we're starting from negative section, the velocity axis here, and then we're approaching 0. And notice that this is a positive slope right here, and the slope of the velocity graph tells us the acceleration, and so that means we have a positive acceleration. Okay, so let's think about what is going on here. What's going on in this situation? So in this situation, we're moving. First of all, what direction are we moving? We are moving towards the origin. Okay, so if this is the origin, we're moving towards the origin, and and then also we are slowing down, so we're moving in the negative direction. So here's what it would look like on a motion map. These are dot diagrams. So dots are getting closer and closer, and so the dots are telling us, this is telling us that it's getting that it's slowing down. Okay, so it's going the negative direction and it is slowing down. These are velocity vectors. The acceleration is positive, and that makes sense because when your acceleration is in the opposite direction that you're moving, then you'll be slowing down. And so that's very consistent. Okay, so once again, what is this graph telling us? This is an object that's moving towards the origin, okay, moving in the negative direction. This is positive, this is negative. It's moving in the negative direction, and it is slowing down. And you can also tell because if you take a look at this little small interval of time right here, you can see that it changed its position a lot. But if you looked at that same interval of time over here, you could see that the position, it didn't change very much, right? So it is slowing down in the negative direction, and that's why the velocity is negative. It has a positive acceleration, and that makes sense because it is slowing down. It's going in the negative direction. Acceleration is positive direction. Whenever the acceleration and velocity are in the opposite direction, you know that the object is going to be slowing down. Okay, the next one. Students also have a hard time with this position graph. Okay, so what's going on here? Okay, once again, we're starting with a flat, so that's a 0 slope, and then it's getting more negative. Okay, so 0 means that it's 0 velocity, and negative here, slope, means it has a negative velocity. So 0 velocity, and then it's negative velocity. It's more and more negative, more and more negative. You'll notice that this is a negative slope, and so that means the acceleration is going to be negative. This is 0 plus negative, so it's going to be negative. Okay, so on a motion map, what does that mean? So what that means is that this object is moving. First of all, it's moving in the negative direction. So I'm going to start over here, but it's speeding up. Okay, so the dots are getting further and further apart. Arrows are getting longer and longer. Okay, so these are the velocity arrows, and the acceleration, you'll notice the acceleration is negative. That means it's going to be the negative direction. Negative direction. The acceleration is in the negative direction. And so that makes sense because if the acceleration and the velocity are in the same direction, then the object will be speeding up. And that's consistent. That makes sense. Okay. So one more graph that I see students having difficulty with is this one. It looks like this right here. Okay. So what's happening here? Let's look at the slope here. So this slope is a positive. So this time we're going to start on the positive part of the velocity axis here, and then it's getting flatter and flatter. So it's positive and it's decreasing to 0. Okay. So this is a negative slope, so I know that the acceleration will be negative. Okay. So what does this mean here? So on the motion map, this is telling us that it's moving in the positive direction. I'm going to start over here on the left. Okay, I messed up my color coordinating here, but let's go ahead and do blue here. And it's actually slowing down. So it's Dots are getting closer and closer. Okay, dots are getting closer and closer. It's slowing down away from the origin. And so that's my velocity. And then my acceleration is going to be in the negative direction. Acceleration is going to be negative direction. It's negative right there. Okay, why is acceleration negative? Okay, it's slowing down. So when an object is slowing down, the velocity and acceleration will be in the opposite direction. And that makes sense, right? So that makes sense here. And so that is consistent with what we have in the graph. Okay, so to summarize here, in the first graph, we have an object that is moving to the left. Okay, so now I'm going to tell you kind of how to describe this in verbal description. So this one, the object is moving to the left but accelerating to the right, right? It's moving to the left, but accelerating to the right, and it's slowing down. This middle graph here, it's moving to the left and accelerating to the left, all right? And so that means it's going to be speeding up. And then this third graph here, third set of graph is moving to the right, okay, in the positive direction, moving to the right and accelerating to the left. And it's going to be slowing down because the acceleration and velocity are in opposite directions.